Good day, students! Welcome to Grade 9 Science class. In today's lesson, you will learn about geothermal energy. For our learning objectives, at the end of our discussion, you should be able to first identify types of volcanoes which can be good sources of geothermal energy. Second, identify volcanoes in the Philippines which are sources of geothermal energy. Third, create diagrammatic representation of geothermal energy flow in geothermal power plant. Fourth, explain how geothermal energy is transformed into electrical energy. Next, illustrate how energy from volcanoes may be tapped for human use. And lastly, identify the advantages and disadvantages of using geothermal energy. Let's have a review to find out what you have learned on the previous topic. Rearrange the letters to find the word. These are natural openings in the Earth's surface where molten rocks, smoke, gases, and ashes are ejected. And the correct answer is volcano. That is right! It is a funnel-shaped depression of the top of the volcano formed as a result of explosive eruption. And the correct answer is crater. Good job! It is a volcanic crater that is formed when a part of the wall of the crater collapses following an explosive eruption. And the right answer is caldera. Excellent! Next, molten rocks inside the earth. And the correct answer is magma. Good job! Magma that has been ejected out of the volcano. And the right answer is lava. Great job! Congratulations, class! Keep up the good work! Have you ever been in a hot spring? We love to enjoy the soothing and energizing effect of water from hot springs. Have you ever wondered where the heat from the hot spring came from? Since our country is home to more than 100 volcanoes, energy has been tapped from them. The Philippines ranks second in the world's production of geothermal energy. According to the Department of Energy, 14.4% of the country's total power generation is produced from geothermal energy. The production of electricity from geothermal energy is cheaper than the electricity produced using natural gas, coal, and hydropower. But what is geothermal energy? The Earth is believed to be extremely hot from within. This heat from the Earth's interior is a source of energy called geothermal energy. Geothermal came from the Greek word geo, which means earth, and therme, which means heat. Therefore, it is the heat from the Earth. Geothermal energy is the heat that is stored deep within the Earth that originates from the melted magma and the decay of radioactive substances. An example of a geothermal energy is shown in your screen right now. Most geothermal energy resources are usually found in the areas around plate borders where most volcanic eruptions and earthquakes happen. In addition, areas with active volcano have high geothermal energy system. This is because the hot molten rock materials called magma located under the Earth's surface may heat the circulating groundwater. Now, how geothermal energy generated? Geothermal energy is generated in two ways. The first way is geothermal power plants. It is where heat from within the earth changes water into steam, water in the gas phase, which turns steam turbines that generate electricity. Geothermal power plants are found in places where it is particularly hot just below the surface, such as near a group of geysers, hot springs, or volcanic activity. They generate energy by carrying heat to the surface via fluid circulation through various types of mechanics. Now, how geothermal power plant works? Unlike other power plants that rely on coal or other fossil fuels to create electricity for homes and businesses, geothermal power plants use superheated fluids from the Earth's geothermal resources to generate electricity. The natural heat of the Earth creates geothermal resources. This heat comes from the molten rock called magma, located at the Earth's core deep below the geothermal resources. Over thousands of years, rainwater seeps through cracks in the Earth's surface and collects in underground reservoir. The magma heats the water until it becomes superheated fluid. To reach the superheated fluid, wells are drilled 5,000 to 10,000 feet below the surface of the Earth. These wells, called production wells, bring the superheated fluid to the Earth's surface where it can be used to generate electricity for homes and businesses. These geothermal power plants uses crystallizer reactor clarifier technology, a process that turns the geothermal superheated fluid into steam while removing solids from it. This steam is used to drive a turbine and generate electricity. All remaining geothermal fluids are injected back into the reservoir for reuse. Under its own pressure, superheated fluid from the geothermal resource flows naturally to the surface through production wells. As the liquid flows toward the surface, the pressure decreases, causing a small portion of the fluid still within the well to separate or flash into steam. At the surface, the superheated fluid and steam mixture flows through surface pipelines and into a wellhead separator. Inside the separator, the pressure of the superheated fluid is reduced. This causes a large amount of the superheated fluid to rapidly vaporize and flash into high-pressure steam. The geothermal fluid that is not flashed into steam in the wellhead separator flows to a second vessel called a standard pressure crystallizer, where an additional amount of standard pressure steam is produced. The flash process continues in the low-pressure crystallizer. The remaining fluid is again flashed, this time at a lower pressure, to produce low-pressure steam. All of the low-pressure, standard pressure, and high-pressure steam is delivered to a turbine. The fluid that is not flashed into steam flows into the reactor clarifier system and is then returned to the geothermal reservoir through injection wells. Turbines are the primary piece of equipment used to transform geothermal energy into mechanical energy. Pressurized steam created from the geothermal superheated fluid flows through pipelines to large steam turbines. The force and energy in the steam is used to spin the turbine blades. The turbine turns a shaft, directly connected to an electrical generator. An electrical charge is created when magnets rotate within the generator. Large copper bars carry the electrical charge to a step-up transformer outside the plant. Within the transformer, the voltage is increased before the power is sent to the power lines that carry it to the homes and businesses. Geothermal energy is a sustainable resource because with proper management, a geothermal resource can remain a renewable source of energy. Water trapped deep within the earth will naturally replace the superheated fluid that is drawn from the geothermal resource through the surface wells. However, it is possible to deplete the geothermal resource by removing fluid faster than it can be naturally replaced. To help prevent this, the steam used in the geothermal power plant passes through a condenser that turns it back into fluid. At this stage, it's possible to recover minerals from the geothermal fluid before it's injected back into the earth. This condensed fluid, along with the fluid that did not flash to steam, is injected back into the underground reservoir. Magma naturally reheats the fluid so it can be used again. Let us summarize the steps on how to generate electricity on a geothermal power plant. First, wells are drilled deep into the earth to pump steam or hot water to the surface. Second, when the water reaches the surface, the drop in pressure causes the water to turn into steam. Third, the steam spins a turbine, which is connected to a generator that produces electricity. Fourth, cooling tower cools the steam, which it condenses back to water. Lastly, the cooled water is pumped back into the earth to begin the process again. There are three main types of geothermal power plants, with the flash cycle being the most common. The choice of plant depends on how much geothermal energy is available and how hot the resource is. The hotter the resource, the less fluid needs to flow from the ground to take advantage of it, the more useful it is. Some details of each plant may be seen below. Dry steam power plant. These plants use dry steam that is naturally produced in the ground. These steams travel from the production well to the surface and through a turbine, and after transferring its energy to the turbine, it condenses and is ejected back into the earth. Next, flash steam power plant. These type are the most common due to the lack of naturally occurring high-quality steam. In this method, the water must be over 180 degrees Celsius and under its own pressure, it flows upward through the well. As its pressure decreases, some of the water flashes to steam, which is passed through the turbine section. The remaining water that did not become steam is cycled back down into the well and can also be used for heating purposes. Lastly, binary cycle power plant. Binary power plants are expected to be the most commonly used type of geothermal power plant in the future as locations outside of the known hotspot begin to use geothermal energy. Geothermal energy in the Philippines. How can we prevent the climate from dramatically changing? By changing to a cleaner source of energy. Southeast Asia is home to 25% of the world's geothermal generation capacity. The Philippines is one of the world's top producers of geothermal power, as it is located along the Ring of Fire zone of Pacific volcanoes. Geothermal energy will continue to be the country's primary renewable energy resource in 2030. Geothermal energy is produced by heat from the earth. It is considerably safer than most other energy sources. The environmental impact of geothermal energy is minimal compared to fossil fuel power plants. Rapid development in many countries has negatively impacted the Earth's climate. Government support and incentives are needed to shape the future of new energy. Will the Philippines become a leading renewable energy powerhouse in the region? Because Philippines is located in the Pacific Ring of Fire, it has many volcanic areas that can be utilized for geothermal energy. Here are some geothermal power plants found in the Philippines. Tiwi Geothermal Power Plant in Tiwi, Albay. Macban or Makiling Banahaw Geothermal Power Plant in Calauan, Laguna. And here are other geothermal power plants in the Philippines. Next is the flow chart, which describes how energy is transformed to generate electricity in a geothermal power plant. Thermal energy from inside the earth. When we say of thermal energy, it is the energy produced when a rise in temperature causes atoms and molecules to move faster and collide with each other. Next, mechanical energy in a turbine. And then mechanical energy of a generator. When we say of mechanical energy, it is the energy that is possessed by an object due to its motion or due to its position. Lastly, we have electrical energy. Electrical energy is a form of energy resulting from the flow of electric charge. Next, the second way to generate geothermal energy is through geothermal heat pumps. Geothermal heat pumps removes the heat from the fluid in the earth connection, concentrates it, and then transfer it to the building. The geothermal heat pump, also known as the ground source heat pump, is highly efficient renewable energy technology that is gaining wide acceptance for both residential and commercial buildings. Not all geothermal energy comes from power plants. Geothermal heat pumps can do all sorts of things, from heating and cooling homes to warming swimming pools. These systems transfer heat by pumping water or a refrigerant, a special type of fluid, through pipes just below the Earth's surface where the temperature is at constant 50 to 60 degrees Fahrenheit. Geothermal heat pumps are used for space heating and cooling, as well as water heating. The benefit of ground source heat pump is they concentrate naturally existing heat rather than producing heat through the combustion of fossil fuels. The geothermal heat pumps take advantage of this by transferring heat stored in the earth or in groundwater into a building during the winter and transferring it out of the building and back into the ground during the summer. During the winter, the water or refrigerant absorbs warmth from the earth and the pump brings the heat to the building above. In the summer, some heat pumps can run in reverse and help cool buildings. How does geothermal heat pump works? Take note of the following steps. First, water or refrigerant move through a loop of pipes. Second, when the weather is cold, the water or refrigerant heats up as it travels through the part of the loop that is buried underground. Third, once it gets back above ground, the warm water or refrigerant transfers heat into the building. Fourth, the water or refrigerant cools down after its heat is transferred. It is pumped back underground where it heats up once more, starting the process again. And lastly, on a hot day, the steam can run in reverse. The water or refrigerant cools the building and then is pumped underground where extra heat is transferred to the ground around the pipes. Let us now proceed to the different types of geothermal heat pump system. There are 4 basic types of ground loop systems. 3 of these, horizontal, vertical, and pond lake, are closed loop systems. The 4th type of system is the open loop option. All of these approaches can be used for residential and commercial building applications. Most closed-loop geothermal heat pumps circulate an anti-freeze solution through a closed loop usually made up of high-density plastic-type tubing that is buried in the ground or submerged in water. A heat exchanger transfers heat between the refrigerant in the heat pump and the anti-freeze solution in the closed loop. While the open-loop system is a system uses well or surface body of water as heat exchange fluid that circulates directly through the system. Once it has circulated through the system, the water returns to the ground through the well. Now let's have the advantages and disadvantages of using geothermal energy. That's the end of our lesson. I hope you learned something new today. Watch out for the next video lesson in science. Answer the questions and activities in your module appropriately. This has been your teacher, Rosalie Custodio, saying, learning science is fun, cool, and awesome. Until next time, students, thank you for watching and have a nice day.